Hey, everybody. Welcome to Beyond the Bench podcast. We have a really exciting guest for you all here today. Rob Taylor, founder and chief technology officer of ChipFlow.
You've never come across anything as stringent as what you get in the semiconductor world. It's some of it's pretty bonkers. What we try and do is remove all the bits of complexity that you wouldn't really want to worry about when you're trying to think about your chip. If we've got a Python-based environment, you can design a chip in like a couple of pages of Python. We see universities around the world now making chips, at least with the masters and PhD students. The EU has recently allocated 70 million of funding for open source chip design technology.
There's good news, there's bad news. Some days are tough as an entrepreneur. What's the driving force? Like, this industry has to change.
It really is that.
Hi, everybody. Welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products.
Hey, everybody. Welcome to Beyond the Bench podcast, Hardware Stories That Matter. We have a really exciting guest for you all here today. Rob Taylor, chief technology officer of ChipFlow and founder, very important. Rob, thanks for joining the show.
Thanks. It's really thanks for reaching out. I'm really interested to chat and tell you what you would like to hear.
All the things, yeah. So I've been following you for a while on LinkedIn. You've got a very interesting background. Can you tell us a little bit, like maybe the 5 years leading up to what you're working on today?
Yeah, I guess so. Yeah, so I mean, just for like my deep background is, I was kind of a very early user commercially of open source, starting in the year 2000. And what I guess about 5 years ago, s- five, four, so 5 years ago, I was working as a director at ARM. Um, just a brief stint there. It was really interesting. Um, and and then it came to lockdown. I was thinking about what to do next. And one thing I noticed was that there seemed to be kind of an uptick in capability and engagement around open source software for building chips.
Yeah, and silicon is like traditionally super closed source, super like tons of secrets, lots of closed binaries. Like, yeah,
Oh yeah. Like the secret levels are way heavier than anything. I mean, I've dealt with automotive and entertainment technology and phone technology many times over my careers, and you've never come across anything as stringent as what you get kind of in the semiconductor world. It's some of it's pretty bonkers.
yeah, absolutely. And so what is like what were you seeing as the actual like entry point? So what was the challenge that you were seeing?
Yeah. So I mean, so the challenge. Well, I mean, there was a certain kind of personal aspect to it, like the going to the conferences those early days. It was like this feels like the early days of open source, right? And I missed those days, right? Or I did, and so there's a certain amount like, oh, this is exciting. There's people who are passionate, and good things are going to happen, right? So assuming this follows the same path as open source software did, it's going to be massive. And so really, but where I looked at it from a business perspective was, through my career. I mean, I've built embedded systems, for 25 years, right? And chips have always been the problem, right?
Yeah.
Whether that's like kind of the availability of the chips you want to use, or the fact that they're terribly documented, and you're trying to write the drivers and get it all working, or like you got into production and weird stuff's going wrong, and you're having to completely like reverse engineer how this thing's working to get the product out of the door working properly. And that's happened more times than I'd care to discuss. And so yeah, I was like, can we bring that same sort of open source, like everything's there, you can see what's going on, you really get in deep with something and have chips which are exactly what you need for your product? Can we Is that gonna be something we can make happen now? Right? And so really ChipFlow has started to, try and answer that question.
And so you work on so what is like what's the two-sentence summary or the quick summary of ChipFlow? What is the service that you're actually offering?
So ChipFlow makes making chips cheaper, easier, and faster.
Very cool. And who are the types of folks that you're working with? The probably not working with the Qualcomms of the world or even the big folks leaning in?
Well, certainly we have conversations with, folk of that ilk, of companies of that kind. should we say. There's there's a fair amount of interest around. Um, I mean, one thing with the semiconductor space is it is a very traditional space, right? There's kind of the way things are done, and that's the way things are done. And really, that comes from the risk levels, right? Because if you're taping out, you know, a latest generation chip, right? Just your test tape out, just your test chip's gonna set you back, tens or maybe even hundreds of millions, right? Um, so you want to make sure everything's right, and people don't like to take risks with that, right? So, um, but then again, the costs are really high, and every company out there faces the problem of where'd you get your people from, right? The problem with this whole space being so private and, proprietary is it's very, there's just so few people who actually know anything about how a chip works at all, right? And that's one of the things where I think open source is actually having a massive effect. I mean, we see universities around the world now, making chips, at least with the masters and, PhD students. And, we're starting to see even like undergraduate courses come online. And there's some wonderful projects around that space. And yeah, and there's I've just been, I'm in a group that's so the EU has recently allocated 70 million of funding for open source chip design
Oh, wow.
technologies. So part of a group that's been putting together, the proposals for that. And we're seeing, universities from across, all of Europe, all of which kind of both trying to leverage their research speciality, but also kind of how is this going to be used inside their tool their education environments. And so yeah, so you've got a big change already happening, which is like there are now more people who can know how to build a chip, and I think that's going to grow quite rapidly, I think.
Yeah, and I would imagine that you're looking at only the biggest companies really house these experts, and before something like ChipFlow, how transferable even are those skills? Like, do people job hop between those 2, or you're just like a lifer at Intel? I feel like the tenure of these companies is massive typically.
Yeah, they don't like people moving because they're so hard to hire. And it certainly, I think it's still a truism. It certainly was a truism, but every person in the UK who graduated in anything to do with IC design was hired by Arm, and they paid a lot for that privilege. How transferable are all the skills? Somewhat, I think, is kind of the answer. The way that each company I kind of builds the chips and has, the kind of the flow is usually very, very custom for each of them, right? But there are some language skills that are transferable, but like your library of things is going to be completely different. How you do things, what your operating procedures are going to be very different. And then there's always some sort of technology kind of like target kind of aspects that could be very different between different companies. So yeah, a certain amount of transferability. And that was actually something that, kind of ARM played a major role in because at one point, the languages you'd write a chip in, each of we call them EDA tools, these, electronic design automation tools. So there's really three big companies, right? You go to for these tools. You've got Synopsys, Cadence, and Siemens. Now it used to be Mentor, and then Siemens bought them. Yeah, so Arm played quite an important role in like 'cause each of these EDA companies had different languages, right? So you could even like if you went to a different company, you were like learning a new language. And Arm was kind of one of the few companies that were using all the tools from all the vendors, right? So they had a big role in kind of pushing a standardization. We ended up with kind of like the C++ of hardware design, which is called System Verilog, which is, it's what everyone uses, but it's very much a design by committee language, right? I think the standards manual's like 2,000 pages long, that sort of thing, right? Twice the size of a C++ standards. Um, but yeah, so that was kind of pretty important in terms of that sort of transferability. But yeah, I think these are some of the again some of the areas where we're seeing effects from open source already with kind of new languages or ways to use kind of traditional software languages for doing hardware and that sort of thing coming along.
And so when does a company decide they need to build their own chip versus buying something off the shelf?
Now that is the big question. There's kind of multiple drivers. So one driver you see, especially kind of in like kind of the defense and aerospace sector, is
Okay.
what's the lifetime of this chip, right? How
Right.
long can I
Right.
expect this to be manufactured? How do I manage the risk of the manufacturer going bust? Because if you've got to be building a plane for 30 years, probably more, right? Because you've got your development period, which may be 10 to 20 years, and then your life of the plane, right?
And so
How do
they
you
would
manage
want
that?
so Boeing would want to own those designs, right? Like entirely. Yeah.
Yeah, I mean, ideally, right? I mean, the problem
Yeah.
is now in most kind of modern planes that they don't, right? They're quite often dependent on Intel still existing, for example,
Yeah.
and still producing the chips that they need,
Hence
right?
hence the US recent investment last week. Yeah.
I was just gonna I was just gonna segue into that. Yeah. You know, yeah, there's a lot of things, lot of national security that probably can't let Intel fail, right?
Yeah. Yeah. Right.
Or at least they're gonna have to do some complicated things like, escrowing designs and making sure that there is manufacturing capacity and it's not easy. So that's one driver. What's your lifetime, your availability, and how important it is for you. Another drive you see is kind of power and space, right? So say I want to make something small and low power, but to make it out of chips that are available on the market, I'd need like 4, 5, 6, 7 chips or something like that. And probably I'm going to have to use a CPU, might need quite a high power CPU, so that's going to use a lot more battery. Whereas if you go for a custom design, you can really kind of make something that's specifically doing the job of your product, right? And make it very, very power efficient in a single chip. And so you the kind of reducing power and space and your bill of materials as well, potentially, right? So if you're going from 7 or 8 chips to one chip, then that can be a big saving, depending on how much you're spending on the chip and what your volume is, right? I think so. Those are the kind of the two major drivers that I see out there. Um,
So just to
Kind of
recap, it's
functionality,
like
right? Is a big one, right? I like can I get the right, especially thing of Internet of Things, have I got the right sensors there, right? Have I got the right interface with my sensors? Um, and, where do I need to put it and how am I going to power it? These are the sort of questions.
so what does working with ChipFlow actually look like? So you mentioned a couple of languages and tools that were commonplace with the Siemens of the world. Like what is like the core set of functionality that you offer your customers?
Yeah. So what we try and do is have, a kind of remove all the bits of complexity that you wouldn't really want to worry about when you're trying to think about your chip, right? So first off, we've got a Python-based environment that you use for kind of assembling your capability, and that it's relatively, and then a chunk of like kind of designer components that you can use, and then you can end up like you can design a chip in like a couple of pages of Python with that approach, and we also kind of allow that enable like kind of standard languages as well, because if you are doing something complicated, you're probably going to try and find like a system Verilog engineer and engage them so that, you need to be able to kind of integrate those different the number of different languages out there for chip design. We try and make sure that you can integrate them. And the other side is like one of the biggest complexities in building a chip is there really is a big difference between when you're doing digital design and analog design, right? And that's because the analog design is kind of affected really by so much specifics of how the manufacturing process of the chip is, right? So that might the foundry that you're using, the specific process, as we call it, of the foundry. You might have heard about like nanometers, right? You're like, it's a 5 nanometer chip or it's a 130 nanometer chip. So process is very much like kind of the size of so that's the size of the transistors on chip. So process would be things like the size of the transistors and kind of how the layers of the chip work out, right? And the electrical and characteristics of that. And also things like the packaging, right? So, like, when you see a chip soldered onto a board, right, you're not seeing the chip, you're seeing like a little, probably plastic carrier with some little legs, right?
Right, right, and, like, so
Right.
the part number on it,
Yeah,
that's
the part
about
number,
it.
right? Yeah, yeah. So that's called the package, right?
Okay.
And so, like, again, like how you do the package is going to matter as well. Like, if you've got very high speed signals, then you need to do things like worry about the exact length of the wires and stuff like that, right? Or how you're connecting them, or how many pins you need to connect it. So all these things kind of have an effect, and especially on analog, right? So what we try and do that simplify that is kind of have kind of templates, I guess we're calling them, or a shell, which is something which which is kind of domain specific, right? So like an automotive shell, an Internet of Things shell, an industrial, shell, and that gives you kind of pre-laid out all the kind of hard analog bits that you need, like to give you the functionality that you need, and then you've got a space in the middle where you can build your own design and do that all with kind of Python, or kind of traditional hardware languages,
And
and
so
build
is
that.
this like a visual design builder, or is it mostly programmatic?
Yeah, so that is something we're gonna be bringing out hopefully in about a week's time. So
Sure, okay.
maybe we'll be able to link to it with when you put this podcast out. But yeah, so we're trying to do kind of at least, it's very hard to do a visual design builder that's like um going to be usable for the whole lifetime of your development process, right? Because there's lots of other stuff that comes in there, but at least something that gets you started.
Yeah, yeah, makes sense. And then I noticed a press release, and if it's not a super interesting topic, we can scrub this all together. But I noticed it was like natural next step is how closely do you work with the foundries? And I saw a something come out that you're now working deep partnership with the company Chip Foundry.
Yeah, absolutely. So Chip Foundry is founded by two of the main people from eFabless, which was unfortunately collapsed. I think 3 months or 4 months ago now, or something like that. But they've done a lot of work in the space of bringing open source design, and they had, the partner Google would partner with them and one of the foundries in the US, a kind of more military aerospace foundry called Skywater. And so there'd been a partnership there, and they'd done a lot of work, and kind of also kind of started to bring, really get this kind of engagement with the academic and the learning communities, right? And so after their unfortunate demise, a couple of the guys, especially the ones that were closest to the manufacturing side, went, "Okay, let's just, like, we can't do the whole thing, right? We can't raise for that here, but let's get the manufacturing bit done." So they're really rolling out that kind of low cost. You can get, I think, 100 chips for 15 grand US, right? Which is amazing, right?
Yeah,
That's
yeah,
something
yeah,
to
yeah.
get to. So they've pulled a lot of the technology out of eFabless, and the relationships there and started that running again. But of course, they don't have all the other kind of cloud and uh, design side that was there with the eFabless. So Mohammed Kasim reached out to us, and we said, yeah, great, let's, because one of the things we think is like this is a very early space, so we try to like have a collaboration happening between everyone commercially released that's commercially working on this kind of open source semiconductor space. So yeah, we reached out and we said, yeah, hey, we can help build like the kind of like a user experience towards
Right, right.
um, your manufacturing flow, right? And so that's hopefully will be released by the time this video comes out.
Yeah, awesome. So you're tackling a huge problem, very entrenched, like prior businesses. Has there been a moment in this where you're just like, oh my God, we're what is it's
Many, right? I mean, like, and we're 4 years in, really, from kind of initial, registering the company name, 4.5 years in, and yeah, certainly, I thought things were going to move faster than they have, right? The semiconductor space is quite slow. And there is this like kind of turnaround aspect, the turnaround time aspect, right? So when you manufacture a test chip, it's 6 months, right? From you pressing send to getting something back. I mean, some places you get down to almost 3 months, maybe 4 months. usually 4 months. But that's a long loop time compared to the software world, right? So things have taken longer than I'd have thought. And there've been times when you can feel like, especially when we're involved in kind of a lot of the geopolitical discussion, right? With Europe trying to really kind of stake its way, and we've had big changes on that front, right? Like with China being banned from using Synopsys and Cadence, right? The two major tools. Um, so yeah, there's definitely times I felt like, oh, someone's pushing in the background here, like against us, right? Um, but really, one thing that's kind of I'm so proud of the team is that for a tiny team, really, we've got a lot of visibility on the world stage, and we know the right people, and we've been instrumental in making some things happen. So that's so sometimes there's definitely times when it's like, "Oh my god, can I not again," or, "Oh, no, it's really tough again." But it's kind of like the excitement really does pull us through, I think.
So where do you get your conviction? So what's the like thing that wakes you up in the morning? Like there's good news, there's bad news. Some days are tough as an entrepreneur, but like what really like what's the driving force? Like this industry has to change.
Yeah, I think it is like it really is that I have always, having been in open source for so long, like I've always think collaboration is like the most important thing we do as humans, right? And that driving, a new level of collaboration in this space, it is really exciting and it's very fulfilling, right? So that really is the core thing that gets me out of bed. I was just gonna, yeah, I'll let you know about one of the the hardest day. Like we had like a 500,000 contract. Working on it for months, like get everything arranged against all the different departments, and then Trump introduced some tariffs, and, and then about a load of bad things happened. So yeah, yeah, it's not the most pleasant business environment at the moment, I would say, right? It's very tough for everyone.
Yeah, I haven't personally made a lot of purchases where I had the tariff impact, but I bought something last week and it was like a $200 part and it came in at $350 and I'm like, here we are. This is
Yeah.
it. Small dev kit, right? But it just had that like huge tariff disclaimer and I just know that this is not helping
Yeah.
things right now
Yeah,
in
yeah,
this
no, there's
space.
such a dampening effect,
Yeah.
and we're I think across the world in a lot of business, there's only a few areas where you're seeing a lot of growth, right? And yeah, so I think it's interesting times to be doing interesting things is what I would say.
Yeah. And the semiconductor space in particular is so global. It is just like one of the most international industries I've ever seen. And I'm sure like maybe shipping and logistics could be more. But yeah, just our journey in this company 2 years into Peridio. And I mean, it's shocking how few meetings I'm having in the US. It's like, are we just moving to Europe tomorrow? Are we moving to China? Like, we moving to Taiwan? Like, what's like, I don't know, like we're happy in the US, but it is a truly international business driven by a few key stakeholders. And yeah, these global impacts are huge.
And that was one of the biggest problems that got hit in lockdown, right? Because spot shipping went from, I think, $2 a ton to $20, right? And then you had all this queuing up of ships as well. And, a single semiconductor parts is probably gonna be going, you know, Taiwan to China to maybe India, Singapore, then, you know, over to Europe, then, maybe back to Singapore, then maybe back to the US, like, there's a lot of water miles on a chip. And I guess that's another area where I think kind of, you know, some of this geopolitical maneuvering, but also the open source side is really gonna have an effect, right? We might be able to kind of really make these things a lot lower carbon cost, right?
Yeah, you empower localization 100%. What do you where are like the regions where you're seeing the most interest and traction? I'm in our last few months, we've seen a huge interest out of India, and it's not a region that I've thought a lot about, but there's so much embedded talent in India. It's amazing. Curious, like what you're seeing.
Yeah, I mean, I've been working with Indians for, 20 years, and the quality of engineering there is really now is through the roof, right? and there's been a lot of kind of government pushed investment in India again into semiconductors and into open source in semiconductors as well. China as well. There's like, I mean, I think we even had, the premier saying that open source semiconductors was critically important, right? Um, yeah. Uh, so and there's a lot of funding there, and then they pushed a lot of money into. So yeah, I think probably about 22. We saw. I was talking to quite a lot of Chinese firms that were getting 10, 20 million each from the Chinese government as they kind of prepared for what they could see coming down the line. And but what's kind of I think one of the things I kind of end up there is they've got lots of these companies do a bit of the thing, right? And whether that all comes together is probably a bit more of a question. Um, but yeah, they've got their own kind of open source semiconductor projects in China. With a lot of interesting work happening there.
It's really interesting to see China in particular really embracing open source because I felt like they were so closed for so long. And then with the AI and then here with this semi conversation, yeah,
Yeah,
it's amazing.
yeah. I mean, I was one of my roles I did in the past was working for an organization called the Open Invention Network, which
Yes, I know these people. Yes.
yeah, so they just for your audience's sake, they enable like the licensing of patents for open source, right? So kind of it's kind of like everyone joins in the pot, and then those licenses become available for everyone to protect against any attacks on the open source space. The period I was there, um, I was which I guess was like trying to remember now. So 17, 18, 19, something like around then. Um, there was, you know, the biggest movers and shakers, apart from probably like GitHub and Microsoft were Chinese.
Wow. Very cool.
They were, and they really had come along so much in understanding the space, understanding how to deal with licenses and how to be a good player and that sort of stuff. Right.
So, very really enjoyed the background. Tell me a little bit more about Rob, the man behind the keyboard. What do you spend your time doing other than programming chip design?
uh, that takes an awful lot of time. I have a couple of kids. I'm separated from their mother, so I have them half of the week. 1 week is mine and 1 week is theirs. Uh, and yeah, my daughter is a firebox, right? She's 7 at the moment, very kind of autistic ADHD, and will never be told what to do, right? She's gonna do something, she's gonna go do it, which I think hopefully will stand her in good stead when she gets older, but at the moment it can be quite terrifying at times.
Sounds like a good open source contributor.
Yeah, exactly. Um, though she wants to be a rock star, I think.
Okay. Fair. Yeah. We all
So
should
she's
come to Nashville, do a Nashville trip and go see Taylor Swift, something like that. Yeah.
yeah, exactly. Um, and yeah, outside of that, I'm a musician myself, and
Oh, very cool.
I like to also just head out and socialize, and go for a bit of a dance. That's my good, especially the way things have been very tense, right? Like go to hit a club and have a good party.
Yeah, I think it's interesting. I was actually writing some stuff last night about our team in this space, and I think there's a lot of really nice threads of creativity required to work in this industry, and there's like so much of it's like so heavy, so waterfall, and it's cool to see such creative elements coming to such a long kind of like stuck industry with like the prior processes and patterns.
100%, and kind of outside the semiconductor space, the whole KeyCAD and PCB way and all this sort of stuff. I mean, that's so different now than it was like 10 years ago, right? It's like ease of building a custom bit of hardware and the amount of kind of open hardware designs out there. So, I'm looking forward to the point when we can, enable these creators to really go deep with this stuff on with their own chips as well, right? I think it's still a journey, right? There's kind of stuff that Chip Foundry And there's another company coming out called Wafer Space, which is also doing a similar kind of thing, that kind of low cost, low volume manufacturing. But you still got your fundamental underlyings of that, which is like, you know, these are big factories that are predicated on volume turnaround time, right? So
Exactly.
we
Yeah.
will we see the same changes in semiconductor design that we saw in PCB design, right? I
Yeah.
very much
Let's
hope
look.
so. And
Yeah.
I think there are
Yeah.
ways, and there are some really interesting, there are some very interesting companies doing some things around that space. Um, Sam Salouf's company in the US, particularly interesting around that space.
What's that called?
I have to remind myself. Atomic Semi.
Oh, cool. That's new for me too. I'll
Yeah, it's
take a
one
look.
to keep an eye on. Which, and we actually, I think we have an investor in common as well. So yeah, that's So I think I will come along, right? But how long it takes and when do people feel confident with it? That's it's going to be a good question.
Yeah, very good question. Well, Rob, this was awesome. Thank you so much for the time. It was great to have you on. I could honestly go on for another 3 hours, but unfortunately, this isn't Rogan. So we try to keep it at 30. But really, really love meeting you, and I know the audience will love it. We'd love to have you back in a few months or years' time and reconnect.
Yeah, absolutely. Looking forward to giving you an update.
Yeah. All right. We'll
My
talk
pleasure.
soon.
Thank you. Bye bye.
All right, everybody, just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.